Alright, in this video I want to cover a couple of very simple rudimentary rules when it comes to dealing with uh, fundamental analysis of series and parallel circuits. They're very simple. In series circuits, resistance is additive. So if I have a 3.9 k ohm resistor and I put another one in line with it, I get 7.8 k ohms, kilo ohms. Um, Voltage is also additive. So if I had a 12 volt battery and I put another 12 volt battery in line with it, I have 24 volts. And current is common. So that means that if I have 1 amp going to the 12 volt battery on this end, I have 1 amp coming out of the 12 volt battery on this end. And we're going to go over that a little bit more in analysis. It might make more sense if you're having issues with that. Parallel circuits are a little bit different. Resistance is added up in a formula called inverse of the sum of the inverses. So you take one of your resistive totals measured in ohms, and then the second one and the third one, you get the inverse of each one. You add them all up, and then you get the inverse of that total, and you'll get the sum of your resistive network. And we'll go over that a little bit more in depth in a moment. Voltage is common. So in this example, we'll have our 3.9 kilo ohm resistors and a 12 volt battery. And if we applied a parallel network across these, each resistor would have 12 volts going across it, which is important for analysis because then you can measure how much current is going through each arm of the parallel resistive network. Speaking of current, current is additive. So if I have 1 amp going through this arm and then 1 amp going through this arm, we have 2 amps. Kirchhoff's law right here says that the sum of all the currents going into a parallel circuit have to equal the sum of all the currents going out. Think about it like it's electrons. So if you have so many electrons going into something, you have to have so many electrons coming out of something. Electrons are a physical object. So keep that in mind as you're doing this. So let's do some quick analysis on a very simple series circuit. I'm going to pull out my little Ohm's Law card and we're going to go over how Ohm's Law is applied to a circuit like this. Ohm's Law is very simple. E equals voltage. E stands for electromotive force. It's a French thing. I stands for current. It's also a French thing. It's intensité de courant, or intensity of the current. So I stands for intensity. And R is simple enough, resistance. So if you want to find one of the values, I want to find current. Okay, in this example, I have 10 volts being applied to 1,000 ohms, and I want to find the current. I cover up the I, I'm left with the E and the R. So I divide 10 by 1,000, okay? And you always keep units. You always keep your units in measure. All right, so that would equal 0.01 because current is measured in amps. That's named after amperes, another French thing, I believe. So that's our first analysis. The current going through this circuit in that direction is 0.01 amps or 10 milliamps. Right, so we did our first analysis where we found it added up to 10 milliamps using our Ohm's Law card. Now let's cover engineering notation real quick because we're going to be dealing with this a lot. You notice 10 milliamps has a lowercase m, and lowercase m equals 1 times 10 to the negative 3. So if I was to say there was 1 milliamp, and current is measured in milliamps a lot, that would be the equivalent of 0.001 amps. Now, it's important to know that that's a lowercase m. If it was an uppercase m, that would be 1 times 10 to the positive 6th, which is a million. So 1 mega amp is equal to 1 million amps. It's like Dr. Evil, 1 million amps. 1 mega amp would be very dangerous. I don't advise playing around with it. Then you also find a lowercase k for kilo, and that's 1 times 10 to the positive 3. And you'll see that a lot when dealing with resistors. So like 1 k ohm is 1,000 ohms. Okay, so this is the basics of what we're going to be doing in this lesson. I'll stick this up here. We'll refer to that later. Alright, so let's do some basic analysis on this really rudimentary parallel circuit. You see I have two 1,000 ohm resistors in parallel with a 10 volt power supply. Or DC, it's a battery, okay? Now, when doing an analysis on a circuit like this, you always want to get these measurements, or these calculations, because you're not actually measuring anything, you're calculating. We want the total voltage in the circuit, we want the total resistance in the circuit, and we want the total current in the circuit. We want the voltage across R1. So if I took my meter, right, and I placed it right here, and I'm trying to read the voltage across this resistor, what would that voltage be? And the same for R2 down here. We also want to read the measurement or calculate the resistance of each resistor, which we already know that's a given. Okay? And then we want to know the current going through each resistor, which you can't measure with a meter like this. But anyway, let's do the measurements real quick. So RT, well, let's go down the list. VT is 10 volts. That's a given. It's right there. R1 is a given. And R2 is a given. So let's find the total resistance. Well, we have a parallel circuit, and we know we have to use the inverse of the sum of the inverses formula, but that's not necessarily true. We can also just divide, because it's two resistors in parallel of the same value, we could just divide it in half. So the equivalent resistance here is 500, but I'm going to prove it real quick. So R1 is 1,000 ohms, and R2 is 1,000 ohms. Okay? And so we need to find 1 over R1, which is 1 over 1,000 ohms. Now always carry your units over. You're not measuring 1 over 1,000. You're calculating 1 over 1,000 ohms, which equals 0.001. It's a measurement called mhos. It's resistance is measured in ohms. It's a measure of opposition of current. Mhos is a measurement of the ability to carry a current. It's the inverse of resistance. So now we know what that value is, and it's going to be 1 over R2 is 1 over 1,000 ohms, and that's 1 over, or that's 0.001 mhos also, because it's the same resistor, same measurement. So we add these two together, right? So then 1 over 0.002 mhos is 500 ohms. Okay, I hope that makes sense. So RT is 500 ohms. So how do we find IT, current, total intensity? This is where my Ohm's Law card comes into play. I want to find the current, so I cover up the I, and that leaves me with voltage or electromotive force divided by resistance. So get my scratch paper. Scratch paper is important. So I want to get 10 volts divided by 500 ohms, okay? And that's going to be, it's a 0.02 amps or 20 milliamps. It took me a second. Anyway, it's 20 milliamps. All right. So now we want to find the voltage or the current going through R1. Okay. Well, if you remember from this chart, in a parallel circuit, voltage is common. So we know the voltage across R1 is 10 volts, and the voltage across R2 is 10 volts, because again, from our chart, parallel circuits, voltage is common. So now we have two of the measurements we need. We just want current. So 10 divided by 1k ohm is 0.01 amps or 10 milliamps. Again, we have the same measurement here. Use our Ohm's law, we cover up I. 10 volts divided by 1 kilo ohm, 1,000 ohms, is 10 milliamps. Okay? So we have 20 milliamps going in. We have 10 milliamps on each arm going out. I'm going to switch to my red marker. Going down each arm, right? And then we have 10 milliamps going this way. And then we have, remember from this chart, current in parallel circuits. Current is additive, and that's called Kirchhoff's law. And then I have 10 amps going this, or 10 milliamps, not 10 amps. 10 milliamps coming this way, and then they add up to each other right here and give me 20 milliamps. Kirchhoff's law says the sum of all current going out has to be equal to the sum of all currents going in, and that's what we have. So in this example, we are able to find the total voltage, the total resistance, or the Thevenin equivalent resistance, the total current of the circuit, and then the same measurements for each component. Okay? And this is just a purely parallel circuit. It gets a little bit more complicated when you add parallel and series together, and we'll cover that a little bit later. So to recap, in this video, we covered a rudimentary series circuit, and we covered a rudimentary parallel circuit. We did analysis on the parallel circuit, and I also covered the basic rules for series and parallel, and we got to play around with my Ohms Law card. If you have any questions, leave them in the comments down below. I'll be happy to answer them. And have a great day.